In the presentation of architectural and urban planning projects, photography is being used, with which many are convinced that they represent reality. In this model, the central frames are parallel, and can be easily deduced from these images. But if the point of view changes, looking at a photograph, each assigns dimensions to the objects represented, based on the presence of known elements. How wide can this door be? What if a more trustworthy measuring element appears? Replacing the camera or video camera certainly does not solve the problem of optical illusions. The presence of a known element, such as a person's hand, it certainly does not clarify the mystery of the chamber of aims. And in this case the robot is no longer smart, who prefers to touch these solids to locate the fake one.
The reference to the risks, which run with monocular vision, was made, not so much to give importance to stereo vision, how much to underline the big difference between the human eye and the camera. The camera, although equipped with sophisticated programs, is always a machine, programmed for certain functions. The human eye, however, is continually subject to brain control, which benefits from a large database accumulated over the years since birth. Just to say, if I throw a jet of water at the camera, it continues to record. If I throw it against the eye, it closes and moves together with the head, but it is necessary to dwell above all on the discourse of the usefulness of stereo vision when we have to make a survey, because it is clear that when I see an object, I don't stop to look. If I look at a chair, it's because I have to sit down, so I check its shape, stability, and this on the basis of a series of experiences accumulated in past years. If we offer an object to a very small child, the child is struggling to grasp it, because it has not yet sufficiently calibrated the brain, which performs the survey, say, dimensional, on the basis of two fundamental elements. The perspective view, that is, he looks at the perspective and therefore, with the reverse procedure, goes back to the dimension. But this process, we have seen, can deceive us. For example, in the case of the Ames room, where, in essence, the room apparently has a square or rectangular section, while it is actually trapezoidal in section, and this would have been seen with the second shot, and surely we would have noticed. as well as for the fake cube. It was fake because it was viewed from the perspective point of view. As soon as we had moved sideways, we would have noticed that the cube was actually a drawing. In addition to the perspective restitution, the other way, followed by the brain, is what, in topography, is called forward intersection. That is, considering that we have two eyes and an observed point, we trace a triangle, which has as its base the joining the centers of rotation of the eyeballs, and as the third vertex the object we are observing. Always remember that the vision of our eye is not at 60 degrees. But the eye sees very well in an angle not exceeding 5 degrees. Practically on an axis. Remember that when I look, I'm going to focus on the detail of the picture that appears to me. Going back to our speech, let's say, about the intersection forward. The most banal example, which we find on almost all photogrammetry books, is that of the two pencils. In essence, I invite a person to put on a pencil, which I hold, another pencil, the tip. He punctually fails with one eye. But here too everything is to be seen, because before placing the pencil, I have to wait for that person to close their eyes, otherwise the other already detects the position and therefore also with one eye manages to center it. Then I have to put the pencil at eye level, so as not to give it a perspective view, otherwise, once again, it would succeed. Perhaps this topic is better seen with a simulation program, with a modeler. We see in the 4 boxes. At the top left there is a plan view, so we can also check what is happening dimensionally. In the box at the top right, there is a perspective view of the whole, with the 2 cameras replacing the eyes. Below we have, on the left, what the left camera sees, i.e. the left eye, and on the right what the right camera sees, that is the right eye. Evidently if we close the right eye and look only with the left eye, however I move the pencil back and forth, this is always positioned on the second pencil, that is the red pencil, that upper, which is that of the guinea pig. The blue pencil is the one I must have in my hand. So with one eye, however, he moves it back and forth. As long as it is aligned with the eye and the pencil, this will always seem centered. He realizes that it is not positioned in the right way. Only by opening the other eye, that is, looking with the right camera. Also in this case I see that the 2 pencils are not centered. Also in this case I can't, only centering with the right camera, because I can center them in 2 ways, moving the pencil both according to the x-axis and according to the y-axis. So probably if I closed my left eye, moving the pencil to the left, I would still hit it. But it is not centered, because by opening the left eye it is seen that it is not centered. So I had to keep both eyes open. And this to clarify an example which, I repeat, in my opinion, already creates confusion, because in the planimetric scheme a segment was indicated on the left eye. The brain does not detect the segment, it only looks at point A or point B, then detects the distance between A and B, based on the evaluation of the visual axis of the right eye.